All right, so welcome to the Research Triangle PowerShell User Group monthly meeting in January. Our topic tonight is Git. Actually, I don't have the topic. I don't know what it's called again, but it's steps to get Git going. Okay,
Git
so
part one.
Git part one. Yeah, it's effectively Git part one. And what that really means at this point is we want to take someone who's never seen Git and try to make sense of it. Now, granted, we're not going to go down, the rat hole, as I call it, but we certainly want to go down the rabbit trail. Okay, is if there is a question that you have and there is something that is interesting to you, and like, I don't understand that concept, we certainly want to encourage that, especially here and especially in this environment. And one of the things that the people online, the people who are in the room, is we have resources to help you, and that's what this user group is all about. This is a user group. We want to get people to interact with each other, but we also want to assist the users themselves. So this is your resource, and we want you to milk the resource in the room as much as you can. And in doing that, we want to just say a level set of what we can do. And so if you have questions, let us know, and we'll go from there. So Git. So let's first talk about what is Git. So a couple slides. This is not going to be really a big slide deck kind of thing. So Git is a distributed source control system. Okay. So what that means, and people use this for source control, is Git is a mechanism to take a snapshot of source code of files, okay, and keep versions of that source, okay, and then it has deep mechanisms to keep differences between those ports, okay. So if you have a place where, hey, I need the my code to change and keep track of it, that is, Git can be a place for that. So one of the examples when you're working with your scripts and stuff like that, you may have, there you go. You may have a folder that basically looks like this. So I have all this. This is one of my actually working folders. And so one of the stuff that I've used in the past. So here's like, hey, move MRU, and then I got this one called PS build, and I got the temp point, and then I have all these other scripts over here with like an underscore in front of them. Hey, I'm not sure I'm working on this one. This is not production ready. So we're going to put some stuff at the beginning of it. And then I also have this folder called like working scripts. Hey, this is other stuff that's kind of temporary. Hey, we got these dashes in front of it. So that's typically what someone's, if they're trying to do some version control, this is like a poor man's version control. Hey, we just rename this, add, something to the end of it, all that stuff. And so Git allows you to improve upon that process and to give you some versioning in that.
So real quick add on to that, Phil. Before I was using Git or version control, I always have a script that I got working, and I would name that underscore working at the end. And then I want to add something to it, but I don't want to break what I know is working. And I create a copy of that that's, work in progress or something like that, that I make all my changes to. And if I completely broke it, I don't have to read that, go back to the original one and start from scratch. So I think that's just trying to plan.
I think one of the other points is that we'll get to some of that later, is there is tooling to allow you to interact with Git in ways. Okay, so if you're using Git on the console, and we'll get to it later. So I expect that this should jump around. So if you're confused, certainly ask questions. But also, I kind of have a roadmap for what this talk should be, or what this session should be. I'm not really going to call it a talk, but a session is in the regard that we want to go down different paths. But the point being, actually, I lost my train of thought and what I wanted to try and do. Oh, so yes, you have multiple versions of this file, but now if you version it using Git, there are tools, Github for Desktop. I just found out today there's Git Kraken, and then there's VS Code and some other tools, and even Git, itself right in the Bash console will allow you to find differences between the same file. So here is my working file, but then also the one before. Well, what's the difference? What did I edit inside of this file? What changed inside this file? I have no idea. I added this part. I want to remove this part. You don't know. And so those other tools allow you to expand upon that. So everybody, there are multiple ways to install it. You kind of actually, this is exactly where, so I'm getting ahead of myself. So Git, you install, everybody here should have installed it at this point, okay? Git is totally cross-platform, so You can install it onto Unix machines, Linux, Windows, Mac. So anywhere Git is available to you, it's there. So it's the same. That component is the same. So again, the tooling that you use, VS Code, GitHub, GitHub Desktop, even the GitHub web itself, and will all allow you to see differences in code itself. So let's do a quick.
One of the cool things I read about was that Microsoft themselves was moving the development of Windows 10 into a single Git repository, right? So as you guys are using Windows 10, it was created using Git with a single repository. So I mean, it's used everywhere, and it's a common platform for developers, but for operations type folks, a lot of people haven't been exposed to the depth of it.
So one of the other things is that I want to do a quick primer. I mean, it's just going to kind of deepen the part, but I want to discuss this, is that what is Git effectively at this point? It's this version. It's not a software application. It effectively is a software application, but as I've heard it described, and it was kind of very beneficial to me. And if anybody else has any other ways to make sense for them, just please certainly share. But when a repository is defined, okay, it is effectively a local folder, okay, that then has a Git repo, a Git repository folder system, okay, that is now managing that system. It is a Git repo, so it's a local folder. It's a .git. So if you've enabled, if you've initialized Git into a folder, you'll always see a hidden folder, and it starts with .git. So on a Windows system, it's going to be hidden. So if we unhide the hidden files, hey, the folder just disappears. So if you look there, it's not there. But if I show hiddens, there is a hidden folder called .git, and in a Unix environment, it's called .git, and it'll be hidden by default if you just do a dir. So that's one of the reasons that it's there. But what's inside of it is there is an entire structure of data that's inside of there. And so we kind of talked before is that when you do things, when you initialize a Git repository and stuff like that, it takes a snapshot of the stuff you have right now, okay, compresses it, and then takes a hash of it, and then just sticks it in this database inside this folder. So Git as a whole is inside this folder, okay? The folder that you're working out inside is called a working folder. That's where the code is, and that's where everything is. And then all of that data and the version and the metadata, as we call it, is all dumped inside of this _git folder. Okay, so understand that there is this folder. There's a ton of data in there. We don't need to go down that rabbit hole or that rat hole, as far as I'm concerned, is to what's inside of here. There's some details. So if you're fairly new to Git, there's a lot of, you don't need to know it's there. Just know that there is something there. So if you have a problem later on, that may be somebody where you can get some more information, but you'll go down some documentation to get there. So there are stages when you're managing stuff. There are files. Just know that there's something called a modified file. So it's now being monitored, or it is now being tracked within Git. The file is now, it can be modified, it can be staged, it's ready to be committed, and then finally it has been committed. And so files are in those stages later on. And so that kind of thing. So this is where we're going to start off with Git init. So Git init is, so you're at the console, we're going to live in the console. There is a Git init. Where's my console? So here's my 00 folder, and that's that folder I was just referencing. So I want to Git enable this folder. Happens like, hey, this is the folder. This is my bunch of junk stuff. Okay, what are we going to do with this? We want to start with Git. So I'm going to say Git init.
And something to be remember here is that this has nothing to do with GitHub or GitLab or like this is all local on the file system.
Correct.
So it's just local to your file system. So without ever pushing anything to any web service, you can track your files and handle all of those things. You can branch, you can prepare your data and merge them back in. Local on your file system. That's what that Git folder is for. That's the application that you're interacting with as you use your data. So when he does Git init, he's making that Git folder in that application, and it has nothing at all to do with anything on the web.
Yeah, so there's no, and so inside of Git, the term is remote, and so it's remote. And the point, like I want to say, he says the web, but I want to think of it as remote because it's almost too much to say. But remote could be a website, could be a GitHub, could be a remote repository, but it could also be a file share somewhere else. It's just another place. And so there is a possibility that I can put my repo, my remote repo, is just on some file share. So it doesn't have to be in there.
Side note, who here has at work scripts contained in a file share somewhere and not in version control? Okay.
Cool. That's me.
Okay. I mean, I have some too.
So, all right. So I said git init, and then right there the response, initialize an empty repository, okay, in the .git folder. So we're just going to do a dir.git. And that's, so you kind of see at this point, yes, it just created this empty folder for me. So now, again, nothing really happened at this point. And at this point, here we are. Now it's just an empty repository. But it didn't, kind of like, what did that do for me? It didn't do anything at this point. Okay? So now, I saw git config, but I meant to git status. So there is this thing, another command inside of Git called Git Status. It tells me the status of what's happening. Actually, this is really awful to show in red. So let's just use GitHub. So we kind of talked about different tooling. So I'm going to show actually a multiple different sets of tools. That this is Github Desktop.
Can you embiggen that?
I'm going to try. Let me see how I can try. I want 0, 0. Can I make it as bigger? So, come on, grab it. All right, so now it says that, hey, there are 211 files that have changed. It's not 211 files that have changed. There are 211 files that I've added to this folder, my working folder. And so now, in this fashion, we can uncheck them all and just add a couple files. I want to do that at this point. I'm going to say these 2 files, and I'm going to commit them. Initial commit draft 1. Commit to master. Boom. So they come off this change history, but there's also now a history. These 3 files have been added. And so we're going to then add the next one. So this is this whole idea. Actually, you know what? I'm going to jump out and do this here. So now we have Git status, and the list is changed. Nothing has changed on the system itself. So as far as the folder structure itself, so the 00 folder structure hasn't changed at all. What we've done effectively is taken a snapshot of 3 files, and then we said, boom, I want to log the fact that these folders are there, okay? And then stick them inside of the repo.
Why don't we stop there and see how people are doing? Because if you've never heard this stuff, it might be.
Cool.
Is everybody kind of cool with where we are at? Anybody have questions?
Question.
Sure.
So, would each individual have their own
Repository?
repository, or is like if you have a team, would that be a shared repository?
So we will get to that at the end.
Okay.
Okay, and that's ultimately what like level 2 is going to be. That the next, is interacting with others. So the idea is that in this folder is this Git folder is local to this machine. Okay? And the reason I say this user and this machine, actually it's effectively to this folder. Okay, because then I can have a different folder that is another Git repository itself. And then kind of why I wanted to talk about the file system is that .git folder. That is the repository. That is the entire contents of the repository. And so when I did a git add, when I added these pieces to that repository, those files were now tracked within that folder.
So should you have one Git repository or multiples?
So this is where it gets to be a little bit more black magic than science, because you can decide what you want to do. So if you were a traditional software developer and you were working on some project, there'd probably be a a repository for that software project. Okay, and that software project would contain 5, 10, hundreds of files that make up that code. For people that do operations or write PowerShell scripts that are like one script, get AD user is, get my AD user, get this group, get that group. A lot of us just work in a repository called PowerShell, and then they organize their folders underneath, like these are AD commands, these are directory commands, these are secure. None of that is right or wrong. It's whatever you work with. This is how I personally do it. If I need to share my code with somebody else, if I want to have I have a repository for my work code, and I have a repository for my code, and my code goes out to GitHub, and anybody can browse it. And I know that anything that's in that repository has no company information in it, no passwords, any of that, right? That may not be the exact same thing that's in the company private repository, right? So that's how I delineate it. Some people, you could break it up and say, I have a repository for Exchange, I have a repository for AD code. You have to kind of figure out what organization system works for you.
Yeah, and it's really understanding the data that you have, and the repository is effectively the folder that you're managing, and that's kind of it. And so you can have multiple local repositories, and they're all repositories. Now, what's inside of them is basically that folder's changes. So if you want to put your files into one folder or group into multiple, there's no reason why you can't have 85 different repositories. And effectively, you don't really think, so you almost want to know that that Git folder is that .git folder is there, but you don't want to know it's there because, hey, it just doesn't really matter. And so you'll go into that folder, you'll do a git push, git pull, or you'll do git add, git remove, and then it'll just black magic it for you. Okay. So as far as we can even kind of take a step back and on your own computer, open up a command prompt, go to any folder that you want to put some code into, or that you have some code for, and then just like git init. Okay, and then we'll go git status. You can see, hey, here's all those files that we currently have. And I'm going to add some more folders.
So I think you're gonna do it yourself. Go to like C10, create a folder called My Repository. In there, create a couple of text files, and you can just put hello world in there, whatever you want to put in there. And then go to a command prompt, cd to that directory, and do git init. And then if you unhide the directory, you should see that .git folder. And then you go over, so you didn't actually go over git add, you just showed it in the desktop.
Yeah, I'm going to do that right now.
So I have a number of repositories in my Git, the guys here as well. If anybody is just curious later on, can stop by and I'll show you how I organize my stuff. And I think you'll find that each one of us probably has our own organization system.
Okay.
That's kind of the beauty of Git. It's flexible enough that you can do what you want to do and the next person can do what they want to do. And all those scenarios will work.
So we're gonna kind of, maybe I should just keep going through a bunch of stuff and then we can just talk about the generic stuff. We're gonna skip over git config. So some git commands that you'll absolutely need later on. And so one thing too is that this is Git. This is not PowerShell. We are a PowerShell user group. So it doesn't conform to the whole verb noun kind of thing. So you say you can git add. So git add is adding a file to be tracked. So a file that's not currently being tracked, you're going to add it to the tracking. Okay. Git remove does exactly the inverse. Hey, remove this folder from being tracked completely. There's a git log to tell you what's been happening inside, what you've been adding, what you've been removing, and all that kind of stuff. Git commit, we'll talk about some more, is what that is. That's the finalization of that. And then git revert is the reverse of that. I want to then revert one of those commits. Okay. So I'll just leave this up there at this point, but certainly go through what you're looking for, and maybe even just walk around to make sure other people are doing it. If you have a question.
No, but I have a question on git init. So when you say git init,
Yes.
so it's going to be record your folder from your C and put in the log saying this is ready for Git into your Git account, GitHub account?
Again,
It has nothing to do with Git.
Not yet.
Right?
Not yet.
So right now, what you're saying is, when you do Git init in any directory, you're saying, I want to create a repository here because I'm going to add files that I want to track the changes.
Okay.
Right?
Yeah,
And so
that's it. And stop.
That Git init will create that hidden folder. And this, like was said before, this has nothing to do with GitHub. This isn't online. This is just that single folder that you ran that Git init in. It's going to start creating the structure for you to create a
Yeah,
Git
it's-
repository.
so it's a
local
Git-
It's like making a watch folder.
Okay.
It's
You're
like-
basically telling Git, this is the folder I want you to keep an eye on now.
Okay.
So Git Initialize is kind of scaffolds what you need before you start actually later on pushing it to a remote
Okay.
branch.
Yeah. So, yeah.
Thank you.
So again, go back to Git status. Hey, we added a bunch of folders and we've committed them. So let me add, git add, get my LAN info. So as simple as that, Git status. And so kind of in the same fashion, so now if I do a git add again, is that this is where I was talking about. This is a staged file. These are files waiting and ready to be committed. Okay, so this now new get my LAN file, and actually I'm gonna do this other one too. Git add move MRU, and so kind of in this fashion, I wanted to show the desktop because so we kind of see at this point is that hey, you can individually add individual files. So git now we're gonna. These two files are ready to be committed. And so in that same fashion, what you'll do is you get a commit, and then you need to give it a message. So also it's kind of great too, is if you don't know all the syntax, it tells you, hey, you have to give me a git commit message. You need to tell me what I just did. Adding LAN info. And MRUs. And so you kind of see it in this fashion. It's kind of good in the desktop. It shows you instead of the desktop. And so it created a snapshot of those files, gave it a hash name, and there's the description it had. It said 2 files have been changed, and it did, that many inserts. Basically, that's how many lines were in the file. And then it created these nodes, that kind of thing.
When you did it in the desktop app,
It did it for you.
with the commit, you added a comment as well. How will you add a
That was
comment?
this message. That was the same message. So git add, let's add something else.
So in Git, when you add messages, you can add a one-line commit message, or you can make almost like if you were writing an email with a subject and more details in the body, like comments about your commit message. The better practice is to write sort of a subject, Rev 2 of code, and then in the body you'd say, fix these bugs, da 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 da. A lot of us just say, push new file, a one-liner commit.
Okay.
Yeah, well, actually, a lot of my commit messages are this, event log stuff, done.
Okay.
So it's not really, so this is also kind of the thing, we're not really developers. And so we're using some of their tools, but, actually some developers are, just as worse with commit messages. But effectively, this is, so just like in GitHub Desktop, you saw here, hey, I can put, this is the Git message. And then this here is an extra description. So let me come back out here to there. So and so if I git commit M, so it's that same thing. So M is the message that it's going to be tracked with. And you notice that there is a new hash of that folder. And are people talking in chat? Are they chiming in? Just want to make sure. So if you're in chat, and even if you have information that you want to share, you're more than welcome to to add.
So when you make a commit message, you can think of that as making a message to your future self. Because what you would use that commit message for is if you want to go back and look at previous changes to figure out what the hell you were doing. So what Phil's talking about is you can be as verbose or as minimal in your commit messages as you want. It really depends how much you're able to figure out from what you did. So for example, if you made 10 commits and your commit messages was stuff 2, stuff 3, some more stuff, that's kind of hard when you look at your change history to say, what the hell did I do in stuff? You may be able to look at the files and figure it out, but it would be better to say, like, added a new file to address an issue, removed a bug, or removed this file that was conflicting, because then your future self can go back and look at it and say, oh, I kind of understand what I was doing there. And then when we go to next month and you're committing code in a group and someone is going to look at your code and try to figure out what you did and if they should add it to the repository, stuff kind of doesn't help them figure out what you've done.
What doesn't go in Git? What shouldn't go in Git?
Well, there's a size limit on files, first of all, 100 meg.
Well, there's a size limit in GitHub.
Yeah.
There's a size limit on
That's
GitHub,
true.
but it can be as big as it wants. Because effectively, I'm using certain words, and it's almost like I don't want to go down into the rabbit hole, but it's taking a snapshot of that file and then putting it inside the metadata inside there. So it can be as big as it needs to be, but then it becomes unmanageable and untransferable later on. So GitHub has a thing, but you can even, in GitHub, you can go beyond that too, but it just converts those into a different form. It's kind of down the weeds, but the idea that it turns it into a, it's a large file format.
Do it.
You can.
You
and
can, but it's not the best practice.
It tracks the
Binaries
files
and
as binaries. Yeah. Yeah, you don't typically put binaries in images.
What's your question?
It wasn't a question, it's more of a comment. Git, SEM, and all of them work best on text files. That's what it's really made for.
Yes.
Binaries, you can store a binary, but there's no manager because you can't see the difference between one binary and another.
Correct.
So when you're storing a text file, when you get that hash, it's only storing the difference between that file. It's not actually 100% copying the file. The reason for that is so that when you look at the history, you can be able to see all your changes. So when you hit something like a blam or something like that, where it'll show you at this time, Paris made a change to these 5 lines and John made a line. So what it's really doing is doing like what we do with Bitcoin. It's sort of creating a journal of all your changes, okay? And by combining all those changes, that's where you are now, right? So it's just keeping a history of that. So you can, the advantage of that is you can go back at any time to get a change that you made, all right? So because at the end of the day, it's still version control, right? I'm taking another version. So if I take a line that's blank and I save it initially, it's blank. Add one line that says Paris on it, then the hash is going to say Paris. But if I make another change and I only change P, the hash is going to be P, not Paris. Okay?
Another thing.
Yeah.
So we did a git add, then we did a git commit for that file that we added. And then when I do the git status, I couldn't see now that
Okay,
file.
so that's exactly where I'm going to get to right now. So we've added a bunch of files and they're now committed. Now, effectively, what has changed in your folder you have? Nothing has changed. So now there's nothing. You've committed all of those things, and so the status is now empty because there's nothing new that is untracked, and you've made no changes to the file. So that's actually where I'm at right now. So while you guys were talking, I now made a change to a file. So now if I do git status, I made a change to a file. It now says that, hey, my git land info script has now been modified. Okay, and so hey, so now it's strictly just been modified. And so now I can git commit again. Updated land info. Oh, it hasn't been staged. Boop. I need to add it again. So now it goes back to status. And so now it's ready because it's been modified. Update the line info. And now this file has multiple versions. Okay. And then we're going to see that in a minute when we go to versions. And so now that the new file has been ready to be committed, it's now been committed. Okay. We still have a couple untracked files. We're going to track them now. One of the things you can do in bulk, you can add everything in your current folder, just by git add and then period. You'll just take everything that's currently untracked, okay, and just bulk add it.
Hey Phil, should you add API keys and secrets and passwords to Git?
No, not well. So the reason I say it no is you can, but you're now putting the secret inside of a repo. Now, if you're going to protect that repository from other things, you shouldn't put it there. Okay? Because if you can't protect it properly, then you don't put it there.
I disagree.
So,
You never do it. Never.
Especially if you're going to put it in some remote one. But if it's something internal for other purposes, yes, you can.
No, never do it.
Can we decrypt or encrypt passwords in that repository?
I'm sure you can put like a public key out there, but I wouldn't even do that. A lot personally, right? I've seen that. That's where a lot of things break down. And that's what shouldn't be in there. Binaries, keys, secrets, yada yada yada. There's a lot of tooling around making that work, right? Because a lot of your code is going to be in Git, but you're going to have to reference, other resources that require authentication, right? And there's methods around. And this is way tangent, but I'm just getting back to it. This is my opinion, right? And I'm not no expert, but don't store any type of keys, creds, API keys, anything in your code. And
Keys.
Yeah, don't do it.
Nothing in there.
Yeah, there's other ways around that, and I think part 2 can be part of that. I think that's an important part of it.
Yeah.
Part 1, just what to not storing Git. Yeah, correct.
Yeah. So effectively, those keys also they shouldn't be. They're not changing in that fashion too. So they shouldn't be tracked. There's no reason to track what the keys were and all those.
It's the wrong use for Git.
Correct. Yes.
Very opinionated opinion.
I agree. I agree.
The key manager to track them.
So we've done a bunch of things at this point, and so now we can come back to effectively one of the next commands we had at this point was git log, and we kind of talked about some of that stuff. Okay. So one of the things that we need to understand with Git, actually, you know what? I'm going to do one more thing. I'm going to make another change to. I don't like. Don't use it. Da, 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 da.
Don't upload your work code to your public GitHub account with your creds in there. Yes. Not a good thing. Don't do that.
You're telling it to watch it. Now you're telling it again to go back in the folder.
Add code. So there's a thing inside of Git, kind of gives you a log. The point being that what we kind of talked about before, when you're using Git itself, it creates a snapshot of this environment, okay, and then records that snapshot. And as you move forward, you can then see differences from files. So we talked about using GitHub Desktop. We can then see versions and as things go. And so one of the points that we kind of talked about before is if you use a GUI tool, Git Kraken, Git Desktop, or VS Code, or anything else like that, you can see diffs. Okay, you can say, hey, I removed this line, I added that line. This line was added, this line was removed in that fashion. So this is one of the beneficial points about using Git itself. All right, so what else do I want to kind of talk about? I hope we're still on track, and I hope people are following.
Are there any more questions?
Any more questions?
Mine are for a little bit further down the road.
What's your question?
So
I'll let you know if it's further down the road.
I think it definitely is. So I had, as Mike advised to not do, I tend to use VS Code to do my pushing to from my local to GitHub and whatnot.
Yeah.
I currently have it in a state of it doesn't want to talk from one thing to the other thing. And so occasionally, since I'm not so well versed in the different parts of Git, I end up always have a backup copy of my stuff, and I end up tending to blow away a repository and just starting from scratch all over. But I'd like to figure out a way how to not continue to have to do that once it decides to not talk to something else. So
There is a website called ohshitgit.com. It will, and I help, sorry. That's a website that'll help you recover a lot of common mistakes that people make, and like, oh crap, like I have to delete my repo altogether, delete my code.
Yeah, so it'll give you different use cases for what your issue might be.
Oh, there's another one. Dang it, Git. Dang it, Git is a
Yeah, that's
non-person.
the same one.
It'll
Just
give you
not.
step by step what you should be running in Git to resolve your issue.
okay.
Yeah. So
But I mean, sometimes I'm not greatest at it. Sometimes it's easier just to copy your code out and reclone your repository and then copy your changes back in. And
Sometimes what I end up doing.
And you might lose some information about your commits, but it fixes your problem. And if it's the quickest way to do it, I say do it. But
That's what I've
I
done.
disagree.
So the use case at this point is kind of what you're talking about. You're using Git and you're talking to a remote repository. And so that's kind of what we're getting to perfect right now. But again, to Mike's point, VS Code kind of abstracts some of that, and they call it syncing and they call it other things. They don't use those Git terms. And so it's sometimes tough to try and piece it all back together. And it's doing a bunch of stuff for you, and it's adding a bunch of stuff to your config file itself. So it's not that simple to put it back together if you get worked up, because 90% of the time you got to go down to the console and do the Git commands themselves, do a rebase or something like that to kind of get yourself back together. But that's where we are at this point. So we're going to talk about remotes. So everything we've talked about at this point has been a local repository. And so think again, I'm coming back to it because it makes sense to me. And certainly, please, people who are more experienced with it, if they have a different vision of what it is, certainly share it. But I keep thinking it's that Git folder, okay? So I currently have this copy of what I have, but it is where the snapshot is of time. And so now I want to take that and I want to put it somewhere else, okay? And so I'm going to go into my GitHub. All right, and let's create a new repository in GitHub. I'm going to create a new repository, and I'm going to call it 2020-00. Okay, I'm going to make it private, right? I'm not going to initialize the thing itself. I'm not going to create anything different. And I'm going to say create repository. So now I have this repository up on GitHub, okay? That doesn't really have anything in it, but this is the URL for it. You can use HTTP, okay? You can use SSH at this point, but it's the easiest thing. So now this repository, I want to say git remote add, and I'm going to add that as my remote. And then the name. Master. Yeah, the branch to be. Add invalid name. Oh, that's what I'm doing.
You can just type. Summary, say commit. You don't have to type.
There you go. Good. Read the error messages. It helps.
Not even the error message. Right there in Git, it tells you we did our Git init, we added
right
our files to it, we did our Git commit. Now we need to do a Git remote add to
There you go.
add it to GitHub.
If you're using GitHub, it tells you right there in GitHub what to do. And then you can say push origin. And so now we can do push. Come back to the command line. We're gonna.
Origin master, can you just do Git push or?
It doesn't know what actually this is upstream origin. It tells it that it is the upstream.
Okay. Because you're doing the -u, you're saying that's.
Yeah, it says push to what? It says my upstream for this repository is that's my origin. So what we've done at this point is then we've taken my local repo, okay, my local repository, and we've now assigned some some remote path. If this happens to be GitHub itself, okay, we said, hey, make that a remote repository linked to this one. And then we assigned the second part is in the same command, push to that as an upstream. And so now we can push to that in the future. And so now if we refresh in Git itself, hey, look at all these changes I just did. But the beauty here is that we notice now too, it says, hey, 7 minutes ago we had this code here, and then 20 minutes ago we had this code. We added all these pieces of code to this as we went along. So very simply, we now have a remote repository. We now have a remote repository that has a copy of everything we did, along with all the changes we made. We added some stuff. We're going to come here to actually this file, okay? And we can then come here to also history and see that, hey, this code has been changed 3 times. So I went through 3 iterations of this code. Hey, it was initially added at this point. Then we updated this. We did some that. Then we came later, and then we added this one. So we added some other stuff.
Can you go back just to the where you got that fatal error? What did you do after that? I lost you after that. You went a little quick.
Sorry, the fatal error. It was actually I just wasn't doing the right thing.
Does anybody
I got the same.
Anybody
I got the same thing, but I didn't see what you did.
Oh, so I changed the fatal error was actually added. I just was doing the wrong command. So it was git remote add origin.
Oh, origin. Oh.
So you need to define what the origin is.
So we left
Actually, it's just a name. It can be anything. So, I'm trying to think of where.
Okay.
Yeah. So this name.
That could be a URC path also.
The name? No. The URL can be.
Yeah.
Yes. So let's actually, hold on. So let me. So in doing this, I discovered here. So git config -l. So we kind of talked about config. This is kind of the weeds, but I think we've gone deep enough into this talk that we can look at the weeds. But the whole point here, this is all stuff that got here. But points that I'm looking for is, hey, this remote thing. So I've defined an upstream that is just a remote other path. It can be some other thing. And so as I get added git push and pull from this folder, it just remotes to that other path. And so that other path is now my remote itself. And so it doesn't have to be a URL. Did that work for you, Stephen?
After you added that, is when you did the push.
Then you do a push minus upstream, origin master, or you can do -u, same thing. Git push minus u origin. So what are you pushing? So you say git push to the upstream, what I want to push, and then what branch you're using. So I didn't really want to talk about branches because that's kind of like a level 2 kind of thing as far as I'm concerned. So 90% of all, you're just getting work. You're all going to live inside this branch called master. It is the master branch. If you want to then work on some other stuff, we'll talk about it next time, is you can branch out and say, hey, I want to work on just this other part, but I want to keep it separate from this, but I want to live within the same working folder. Then you can branch off and then you can keep branches. You can merge branches. You can branch off again. So that's kind of a different topic.
It is something that when teams work together, if you work in with more than one person, branching is pretty important. So
yes,
but we'll get there.
So effectively, we have this work here, and we pushed it up to our remote repository. I'm going, okay, so now what do I do? So now, hey, now I have my remote repository. And so in this vision of what a sysadmin would typically do is, hey, I'm working here in this PowerShell console. This is me working at work, okay? So now I want to go home and actually access that same repository. Actually, I'm going to jump out, and so I'm gonna say GitHub. Yeah. So I want to now work on in GitHub. Okay, I want to work on my. This is my in this PowerShell 7 console is now home. All right. So I want to get my code that I had in my repository remotely.
Yeah.
Okay. If you're using GitHub itself, the website, you can go to clone. There is something called clone, and that is the copy. You can copy this path. But now what I want to do is git clone this repository. Okay. And then you can give it a name. Work. So if you don't give it a name at the very end, it'll simply use the 2020.00 name, or you can name it to something else you want. So it doesn't have to be the same thing. So I'm going to simply do it and see. It says cloning 2020.00. It got that entire thing. What it happens is it downloads that entire Git folder. Okay, the Git folder, the .git folder, and then it actually checks it out the entire master directory. So now in this folder is an exact copy.
But there's nothing in GitHub. Right?
Is exactly what we kind of talked about before. So now here is another copy. I think this is 2 different computers. So I can't do it. So this is a remote computer. So now I have at home, I have an exact copy of what is in my repository from work that I had pushed up my code. So I took my code at work in its local repository, pushed it to GitHub, and now I've pulled it down from GitHub to my home computer, living here. Okay. So does everybody kind of understand that at this point, or kind of confused? So you know what? I think I'm gonna get my land disk. And I say go and fix that command that I didn't like. Are fix this. I don't know. Just trying to make a change to that file that we saw before. Okay. So now we close that file. So now Git status. So notice here at this point, Git status and all that, it's all work. It's the same thing. So now we're at home. We're doing that Git status. We're doing Git add, Git push, merges, Git add, $, Git status, ready to be modified, Git commit, fixed the description. All right. And so just like before, now we're at home. What do we need to do? We can just git push it. In this fashion, in this case, especially, so, Stephen, to point out, is that we don't need to add an upstream here because we cloned it from the remote. So in this fashion, we went and got somebody else's repository. Well, effectively it was ours. But the same thing happens if you're going to clone, you hey, you go to some GitHub account, and hey, somebody's working on something. If you clone it, it's already assigned that remote to that machine. So it already is there. And so you then push, it's pushing back up to GitHub.
Wait, so if you're pushing, are you pushing to the local, the cloned repository or the GitHub?
Push to the remote.
Okay.
Okay, and you may not on in the blue screen, okay, in that screen, at work or whatever you want to call this, in the blue screen, we initialized a brand new empty repository. We added a bunch of files. There was no remote there. So we had to add git remote add.
Right.
Then that URL, which is our GitHub repo. Okay. So we added that remote inside of that local repository.
Okay.
So then when we came home into this black window, okay, we then just said git clone the remote to me. And so now we have a local copy of whatever that was. Now I have my local copy, so if you push back to where its remote is. It came down with the remote.
Okay.
Or the remote has been set to where it came from.
Okay.
So kind of in that Control L. So again, you can kind of see here at this point, git config -L. It tells you, hey, the origin is exactly, we didn't put that in there. Okay. So it put what the origin was. And so it came for free. Call it that. So.
Oh, can you,
What's your question?
Bill, I'm sorry. On that one, it shows remote origin URL, whatever.
Yep.
Whereas on your other one, it showed remote upstream.
Yep, because I called it upstream.
Oh, you called it, I thought it was still called origin over there. I'm sorry. So you called it upstream, and that's why it
Did I
showed
call
up.
it upstream? I thought I called it upstream.
You may have. Hey, you can just do git remote, and it'll tell you, right?
Actually, let's find out what it says. Config minus L. No. There it is, called origin. What was that upstream? Maybe it was in a different folder.
It's the one where you did the -u when you did it, and
No, but yeah.
you
So
did
minus U, and that minus U is short for upstream.
right, but it's called origin.
Yes, I called it
And when you
origin.
did this list a while ago, it showed remote.upstream instead of remote.origin. I remember noticing that. Maybe I'm brain dead, but.
Branch master. There is an upstream, but I think it's just another remote. But again, it's just a name. Don't think of it as origin or upstream. It's an origin upstream. These are just.
I just never used the -u option, so I was trying to figure out what the difference was.
Yeah.
So question, a couple of people have a way of working that's probably different than the way we normally do it. They're creating a local folder and a remote folder, and they want to sync them together. Basically say, this local folder should point to this remote. I don't normally do it that way. I usually make a remote and clone it, or I work local and push it up. Remote made, but I'm not sure how to rectify that. I've made a local repository.
Yes.
Called repository 1.
Yes.
And then I go over to GitHub and I make a repository called repository 1, and now I need to tell my local GitHub, local sync up to remote.
Correct.
It's created the folder, the same folder on both sides.
Correct.
How do they sync those two together?
That's exactly what I showed here.
Okay. I was talking separately, so I think there's
So
a few
if
people
that didn't work for somebody, or that something's not working, one of the things that we may have a problem with some of that is if you created the GitHub repository and you initialized it, you actually created a new commit into it with like the initialization, hey, have a readme and all that kind of stuff. You created a new, you diverged the heads or the last commit. Okay, so that's this concept of, I didn't want to get down that road as far as heads and commits, but you may need to get there, is you diverged it. And so now you need to rectify that conversion. So you need to then pull down, you'll need to set up the upstream, pull it down.
Or delete one side and start over.
Or delete one side, yeah.
So I have a question here.
Yes.
Is that local repository name and the GitHub repository name should be the same or different, and you can sync it?
There's no files in there right now, right?
By practice, they should be the same. They don't have to be the same.
You should start in one, either push it together or clone locally.
Okay.
You shouldn't create two different and then try to merge them.
Okay.
So when you create it on GitHub, like you said, a lot of times if you create a README and all that kind of stuff, you're initializing and you're creating files in that repository. Even though you didn't actually make the files, it creates a README and stuff like that. So you end up with your local has file A, B, and C, your remote has file D. Now you're trying to say, hey, push all this stuff up there. And it says, wait a second, I already have stuff up there. And you don't have that stuff there. So do you want me to delete the stuff up there? Do you want me to add? What do you want me to do? And so it's a lot easier if you start in one place and either push up or start,
Okay.
in GitHub or wherever and clone it down.
Okay.
Yeah, and if you have a problem with that, come see me and I can show that example of, breaking it, and then we can fix it. But I don't think I want to go through that right now.
So you can fix almost any of these issues. It's just you go beyond the basics a lot of times.
Okay.
And the thing that the guys were just talking about is, remember, when you make a folder in GitHub or you make the folder on your local repository, you're making a folder. When you initialize that, you're basically creating a reference, what Kevin just said. And the reference says there's no files in here. And then you create another one on the other side, and it may be a little different. And GitHub is going to try to figure out the differences between, and it's going to say, you need to do something now, because these two folders are not the same in its eyes because they have different reference points. So there's a way to merge those together. But most of us, we either create something local and we push it up to the remote, or we start with the remote and we clone it down locally. And that way, both sides are at the same reference.
Yes.
And from going forward, they're together.
So the last point I want to put out is that kind of now we've escalated to the point where now we have effectively 2 local repositories on different computers. We have 1 remote repository in GitHub, Bitbucket, some remote, okay? And then we got to keep then what we want to describe at this point. So I'm going to come back to, hey, so I was back here at home in the black screen, and I created a new commit. I did some edits back to this file, and I pushed it back up to remote. And so now back into work, I'm going to come back to work on the blue screen, and then how do I get it back? So this is we initially pushed it up to there, and now I want to get it back. Okay, the first time I got it back is I had nothing, so I cloned from there, so I created it. But effectively, it was a pull. We did a pull and a checkout. We don't need to talk about that at the point. We did a pull and a checkout. So at this point, I already have my local repository. It knows what its remote is. It knows what its upstream is. At this point, all we do is git pull. And now we see, hey, the remote repository is beyond where I am. So I need to pull any new changes. Those changes can be in 5 different files. I can now move 5 files and everything. And you see it says here, hey, I have this my file, 2 lines were changed, 1 file changed, and inserted 1 here, and it deleted 1 line. So it kind of says, when I now pulled back in from the remote, here's how I do it. So we have, first, get your initial, so yeah, I think that's at this point. Then does everybody kind of understand that? So the practice when you're working with 2 repositories, both on 2 different computers, is you're going to be pushing and pulling from those typically. Okay, when you first start out, you're going to do some other stuff. You're going to do a clone typically, and then you'll have to maybe fix it if you don't start from brand new places.
Phil, could you just go over one more time for Lars? He's got a local. He now wants to point it up to GitHub. That's
Yes.
Remote, right?
Yes.
The syntax.
You're going to git remote add. It's and it's there. Git remote add. And then you're going to give it a name. It's basically what you're going to call it later on. Okay. So that name could be anything. We just call it origin, typically called origin, and then the URL that you're sending to.
Right.
But the URL is one that I'm creating for the first time now, or something that I've already done on GitHub?
It's already been created in GitHub.
So he deleted his repo on GitHub.
So there's a trick to this. When you create the repository on GitHub, and maybe you want to show it again, do not initialize it and create a README and all that kind of stuff. Because that's when you run into the issue. Because what ends up happening is when you try to rectify that, it says I have this repository. So essentially what ends up happening is you have like commit, and if there's a commit that's up here, that's not down there, and they're not like in line, essentially what happens is, hey, we have different files here than we have here. How do you want us to merge these different commits that don't exist in both locations, right? And when you have a README here, so file B here and A, B, and C here, it says, do you want me to actually delete A, B, and C to get to the point where I just have D? Or do you want me to create A, B, and C and delete D here, right? It has no idea what to do. So as long as when you create that repository in Git, you don't initialize it and have files there, then you're able to add it and say, hey, push all this stuff up there so it looks like this.
Okay.
Right? Does that make sense?
Don't add anything to the remote one, just create it.
So I don't know if you.
Yeah, I'm as you're working, I'm gonna reproduce that exactly right now. So initial commit.
I honestly don't work that way. I work in reverse. Is I create it and get wherever, whatever. I clone it down locally. I copy all my files that I want in there. I git add, git commit, git push.
Okay.
That to me is an easier process. And if I know those, and git pull, if I know those commands, I've worked with those forever. And there's a ton of other stuff that,
Yeah. So effectively what he's doing is doing the remote build, and then he's doing the clone, which is the full along with the doing the remote connectors all at the same time. And so when he builds the local, it is from the master. It's from, excuse me, the remote. And so you can do it that absolutely can do it that way, but it's just differently. And so if you start with the remote, start with the local. So now I just added it here. So now I have this new folder called 99. Okay, so 2020 99. I'm going to come back to GitHub. I'm going to add a new repository. And actually, you know what I'm going to do is I'm going to call this fix. So that point is that it doesn't have to be anything. Okay, we're going to say private fix example. And then we're not going to check this. So I'm going to call it whatever. This is just some repository name. It's just the name. Who gives a heck what the heck it is?
Yeah, I got it.
Doesn't matter. Okay, we're going to call it private because I don't want to show it out. Okay, and I'm not going to initialize this. Or actually, you know what? I think we will initialize it. Okay, so we're going to actually that was the example. So we're going to let it go initialized. But you know here what it says? It says, hey, there is an initial commit called the README. It created the README for me. All right. So in this example, now, yeah, here. So if I git log right here, I have an initial commit already in my local. Okay. So now if I want to add git code.
This one, but actually my actual GitHub account is
add origin.
my private email. This is a company account.
So
actually, we can call it foobar, or I don't know, foobar.
Yeah.
It doesn't really matter, but I want now this. I'm kind of throwing out just generic at this point. So at this point, now I have that. Okay, so now if I wanted to git push minus upstream foobar, because I have to do that, master. So this is kind of what you're doing before. It's going to try and do it, but oh, it was rejecting because it already has some stuff in it. So now I need to pull what's there. Actually pull foobar because that's my remote. Okay, and then master. Pull foobar master. So I can pull that. So now I have this new thing called foobar master. All right. Git status.
That's that fatal message at the bottom, right?
Okay. Actually, I think I need to merge them. Huh. I didn't really want to do that. Oh, sorry.
You have it on me, and I tried to change it. You can say, hey, Mike is already.
Oh, yeah, that's why I didn't spell it right.
Oh, okay.
The person can make unrelated histories. Oh, because yeah, it won't even do it because it's an unrelated history. I think I need to pull it. So at this point, you just, yeah. I don't remember what you do here. So I got to talk to Joel Shallow.
He's on the.
Oh no, what do you say? What's he say? How do I fix it?
What's the question?
The question is how I have now diverged two histories.
Joel is right around. They'll help. And Steve.
So they'll get you up. But the point is, I thought I've done this. I've done this before, but I don't remember how I fixed it. But I try to remember here. What? I don't know. Git sync. Let's try that.
Yeah, refresh.
How are we doing online?
I think it's git hyphen sync, isn't it?
What?
Git hyphen sync?
I don't know what Git sync is. I don't know what that is. Install SVN. No, it's not.
Oh, you didn't add anything yet.
So.
Oh, it says it's.
A bit of LS right here.
Most command is SVN. I've never done it, but.
Oh. You don't want your root.
Yeah, that's right.
Yeah, you want to create a separate folder somewhere else.
Do you want to set tracking information for this branch?
Right. You don't want to commit
No.
Yeah. Go to like documents or something.
So while we're doing this, does anybody have any questions for Phil that they want to think through, or online? Is there any questions that we want to pose to the room or anything like that?
Yes.
It's 8 o'clock. We're pretty close to where we would normally end, but we can go as long as people have questions or things they don't understand.
Sorry.
Sure.
So one of my classic things with Git is I've got a repository, I got a bunch of files in there. I refactor my code a little bit and I no longer need a file, so I delete it.
Yep.
Okay. I do the commit and so on. A couple of weeks later, I'm like, is there something in that file I'd like to see? So I want to go back and see that file. There is nowhere that I've found that will even tell me what the name of the file was, because it's not in my folder. I guess you have to go back and dig through your logs, but how much changes you made, and so on. Anyway, and maybe there is, I just don't know about it. What files have been in your repository and have been deleted?
There's a Git. I don't remember the exact command. Well, you get. What's the Brett saying on mine?
You can go through your log.
Open up. What?
You can go through your log and you can use Git checkout to see history there.
So I don't know. Can you hear me? Hello.
It's God.
Yeah. So if you go through the log, and if you've got a specific commit message in there from when you deleted that file, you can do a Git checkout from that file.
Right.
From that using the SHA-1 hash, and you can check out the repository from that point in time. You can also create a branch from that time, and then you can pull files between branches using Git checkout.
But is there a way to go find that file from that time? I think, isn't there a way to go and, hey, I know it existed on the 20th.
So there's Git,
I think there's a way to look through the log.
Yeah, so there's Git blame.
Git blame.
So yeah, and then there's Git diff, so you can diff what head currently looks like against a specific SHA-1 hash. So
and I know in the GitHub,
ideally you're relying on the Git log. You're relying on the Git log and being able to go back in time to see what it looked like at a specific point in time. So you can say Git checkout, put a SHA-1 hash in, which you can pull from the Git log and see if that file's there. If not, you can go back to the next commit, the next commit, and then you can compare the branches back in time to see how they differed. And you can use Git blame. So if you go into GitHub, you can use Git blame to see how specific folders and files looked from a particular point in time and how it looked from the previous commit.
What word is he saying? Git blame?
Blame. Like I blame you. Yeah.
So if you click on any of the files in there, so get hung, print queues, or anything like that, you've got blame at the top there, raw blame and history. And then if you scroll down the left, you see on 38 minutes ago, you've got like the little squares. You can click on that and it'll take you back to how that looked prior to that change when it was made 38 minutes ago. And it'll show you the previous change, and then you can click back again and go back through the history on that file was when that file was last changed. So if you know a specific change was made in that file, you can use the blame to go back to see who made that change and when.
Right. That doesn't work if the whole file was deleted.
No, that's where you have to use Git log to find out when that file was changed. Yeah, you need a rough idea of when it happened, and then you can say Git checkout, use the SHA-1 hash that you retrieve from Git log, and you can check the repository out as it looked at that point in time when that commit was made in the log.
Yes.
Okay.
You can even then, when you get back to that, you can then create a branch from that point in time, and then you can use Git checkout file from a particular branch, and it'll pull the file from the branch you've just created into your current head. So I've done that before. Where I've restructured an entire Git repository, and then decided that, oops, that structure doesn't work, but I need to keep the files how I've currently got. Created a branch from where I was, and then pulled files between the branches using Git checkout. So you do git checkout branch that you want to pull it from and the file. You can even do particular lines from a file if you really want to. 36 to 38 was changed, you can do a git checkout master branch this file and these lines, and it'll pull those changes into your current master branch.
That's part 5.
But all I'm demonstrating there is that the log has everything in it that was changed throughout time. Right. That's how powerful the log is. You can go back in time, see how things used to look. You can check out those at any point in time and then pull changes between previous changes, previous commits, previous branches. And it's really it gets very in depth very quickly. But this is the whole, do I just start again and clone my repo again and then redo all my work, or do I spend a little bit of time figuring out how to undo what I've totally broken without having to recode everything? So, but yeah, you can do git log, find the SHA-1, git checkout of that SHA-1 that'll take you back in time. You haven't lost anything that you've changed because you haven't overwritten any of those changes, and then you could effectively make a branch from that checkout and then pull those changes from the new branch into where you currently are in head or master.
So Brett kind of went down somewhat the rabbit hole to talk to individual files and something from his point of view. But what I've done similar to that is, yes, go find the time and the time and place, like he said, and do a checkout of the entire thing. So now this working folder, the folder you're in, is now where it was, 3 weeks ago, right? And so then what I've done at that point, like I didn't know this other stuff with, hey, can you check between branches? I just go, hey, now I have a copy of this file. I copied out somewhere else. I then pushed myself back all the way to the beginning and going, hey, now I have a copy of that file. And then I pushed it back in. And so that's what I've done in that past. So it's kind of like just check out the whole thing, pull the pieces out like separate from Git, and then put it all back together. So that's one way to do it. That's how I've done it.
Yeah, and that's exactly what I've done in the past as well. But then I forced myself into a situation of saying I need to learn how to do this with Git. So, but as long as you and as long as you know you can recover your files because it's in the history of your Git repo, then you can save yourself a lot of pain by just knowing that it's in there somewhere and how to get to it from the log. And Git checkout is how you would do that. Whether you copy paste that, whether you use some magic or sacrifice your firstborn to get that back into your repo, it makes no difference. As long as you know it's there and you know how to get to it, you can save yourself a lot of pain.
That's when you find Joel Sallow or Stevie Velding online.
When you get Brett, man, that's our peach from across the pond, man.
Joel has unborked my repo a couple times.
Well, I think one of the important things though is you had mentioned going back to the logs. Your commit messages are going to be really important to easily finding where you deleted that file. So your commit should say, I removed some file, and now just in your log you have the name of that file, right?
So one of the stories that I tell when I give my GitOps session, which I'll be delivering at PSCon for you, is I learned Puppet in German from Git log messages. I got given a new system that I didn't know was in German, was all in Linux, which I'm terrible at. And the guy who left me this system had a Jira ticket number, messages which told me exactly what he was doing and when. So I was able to say, right, okay, he gave someone access at this moment in time. I'll do a git diff on this SHA-1 hash to see exactly which files he changed in Puppet, which was able to grant people access to whatever they needed. So by having git log messages, commit messages, which tell you exactly what it is that you're doing in a succinct way, you are able to go back through time and find exactly what you need.
Okay. So at this point, kind of like this is the great point where we've now kind of discovered that, hey, there's more information here, and there's more that we can really do. And so ideally, what we'd really like to get people to do is try and use some of the things we've talked about. I'm going to put all these little repos kind of thing what we kind of dealt with, like up in our GitHub repo. So you're feel free to actually pull that down. The RTPSUG repo has stuff in there. You can pull other stuff. You can practice. Hey, build your own stuff. Push it up there. Mike, me, we're publicly accessible. There's easy, Jonathan and a bunch of people online. Let's practice what this is. So in 1 month, we're going to come back and we're going to do more of this. Hey, we're going to play with branches. Hey, we're going to play with a lot more checkouts. We're going to forking other people's branches. We're going to be merging with other people and trying to really break things so that we can figure out how to work with this and get and working with other projects and contributing to other projects. And that's kind of the objective into the next part. So hopefully we went down some rabbit holes, but also we didn't get too deep where you couldn't get things operational. And we wanted you to get at least something operational. We certainly want you to practice some more. And so that when we come back again, you'll have really good questions, really good examples of, hey, I tried this, but it didn't work. But also certainly don't wait till a month from now and go, hey, let's talk about this, because we'll want to cover some other topics, but we also want to answer your questions in that time frame. There are a ton of resources online, so you can certainly read the docs themselves, or you can simply pose your problem, your scenario with you, and then share it with us, and we're more than happy to find the right people that can help you. So this is a user community. We want to interface with you.
One of the references I mentioned in the chat was the Git channel in the PowerShell Slack and the PowerShell Discord also.
So if you're in Slack or Discord, there is a Git channel, and yeah, those are great resources.
So real quick before people take off. So as Phil started to highlight, we're going to do a part 2 to this next month.